Swayam Prabha. Digital India. Educated India.
Hello everyone, we are back to the particular class where we were talking about the analysis of mental workload and human behavior, right? Okay, now today we will be discussing a very specific tool, we call it as multiple resource time sharing model, okay. So, multiple resource time sharing model, from this particular name we understand where there will be a single resource where multiple tasks will share that particular resource, or there are multiple tasks where one single resource will be giving the input towards that, okay. So, multiple combination of tasks. So, here the lot of interactions will be there with the human, with the machineries and the resources in a particular system. So, I always suggest all of you to please remember the understanding of complex system, complex ergo system, because if you go to the industry, we will come to know that every system is very complex in nature. So, it is not one man, one operator, one machine and one in a single environment. It is always multiple in nature. It is interacting with each other in different domain and different dimensions, right. So, this particular analysis or this particular method actually help us that how we can improvise on our, or how we can optimize our system so that the productivity is good, and our productivity help us to get more performance, okay. So, whenever we are talking about implementation of ergonomics principle or ergonomics theory in a particular system, our always goal is to enhance the productivity, whereas we want to save or we want to enhance the well-being of the operator, right. So, this particular theory or this particular model actually make us understand that how we are sharing the information or the sources in a particular system to complete a whole job. So, it is multiple resource time sharing model, okay. So, let us begin with the detail of the this particular method. So, what it says, it predicts the degree of interference, okay. It helps us to understand the degree of interference between two time shared tasks. So, if there is a single two tasks where within a single time that both the tasks need to be completed, what are the varieties of interference are there, so that once we understand that what are the interference, how we can change it, or how we can monitor it, or how we can do the improvisation on that, so that our final productivity is good. Okay, so it predicts the degree of interference between two time shared tasks. It predicts the loss of performance. Actually, it predicts the loss of performance of one or both tasks carried out concurrently relative to their single task baseline measure. Okay. So, when there are 2-3 tasks going simultaneously, of course, we can have an understanding if this task 1 we do at a time, there is no task, what is the kind of time taken. for task 2 also we have some kind of measurement, task 3 also, task 4 also. Now that is the individual baseline. Now with this particular model or particular method, we do understand if these 3 or 4 tasks are being carried out simultaneously, what are the time interference and what is the loss of performance in the whole process. So that we will come to know. So if the loss is too high, then we really need to understand where the intervention need to be given, or where we can start the design changes so that the performance is not being hampered. So its effect on the performance, in which the sources of workload are multiple task demand, and this particular model is based on the multiple resource theory. This particular model, that multiple resource time sharing model, is based on the multiple resource theory, which was first introduced in 1979, and over the period of time it has a lot of modifications. So first let us understand, or let us take some input from that particular theory. So in Wickens, like whatever Professor Wickens said in 1980 and in modified version in 2002, he said that multiple resource theory suggests that several different cognitive resources can be used simultaneously. Okay, so different cognitive resources can be used simultaneously. So it has a typical structure of this particular theory. It says it can be majorly two types. One, that is different tasks require the same cognitive resources. Different task requires same cognitive resources. Another says same task require different cognitive resources. Okay, so I am going to give an example. So different task. Okay, you are writing and you are speaking. Okay, in these two tasks you need one specific cognitive resources to support it. So that is one thing. Whereas the same task, okay, you are writing only, however you need two cognitive support or cognitive resource to write that. So this is the two different varieties of example. So multiple resource theory says it can be two different way. In one case, different tasks require same cognitive, one single cognitive resources, whereas a single task may require two varieties of cognitive resources. In the first case, that visual perception information must be processed in a sequence. If two tasks requires single multiple cognitive resources, in that case visual perception information, those things must be processed in a sequence, because you cannot have you cannot do it simultaneously, right? So for each task you have to have a sequence. Here comes the interference. Okay, in the second case, visual perception, auditory perception, both the things can be processed in simultaneously. Okay, so if you need suppose I am talking about writing. In writing, if you need visual as well as auditory, you need to process it simultaneously. This is just an example. Okay, so when we are talking about in industry, there are no sets of big system where a lot of informations are processed by a single person or single operator or multiple operators at the same time. All these scenarios can happen and we need to analyze it, and using this particular method or particular model we can realize or we can understand where are those interference, and where the interference are difficult to handle, we need intervention over there. Okay, so this is the importance of this particular theory. Now when we are talking about these things, let us understand more into detail about the factors. Okay, here it says, multiple resource theory says, three different factors are important in predicting how well or not a task will be performed when time shared with another. Okay, so when I am talking about multiple resource theory, it says there are major three factors. One factor is difficulty or demand, job demand, then is extent, and the third is allocation. So these three factors are important in predicting how well or not a task will be performed when time shared with one another. Okay, let us understand more into detail. When I am talking about difficulty or demand, it says difficulty or demand for resources of each single task component. Each single task component, it is not simultaneously all the tasks. Each single task we have to identify. So driving in a traffic example is more resource demanding than driving on an open area, correct? So you need lot of resources because you need visual, you need your skill, you need your auditory resources, all these information, some background understanding, everything is required, right? So this is when we are talking about driving in a traffic. So understanding the speed, so all these perceptions are understanding the signal, everything. Whereas when we are talking about in a open road, of course it has less demand. Just an example. Now when I am talking about extent, what it says, extent to which the two work task demand common or separate attention resources are required. Okay. So for example, in any vehicle, visual display will demand more common resources with driving than will an in-vehicle auditory display. Of course, in-vehicle visual displays are more informative, more required than the in-vehicle auditory responses. Now coming to the allocation, it says allocation of those limited resources between two time shared tasks. If there are 2 or 3 time shared tasks, how you are actually allocating them. So driving is emphasized at the expense of using in-vehicle technology or the converse. Okay. So these three factors we are going to consider in this multiple resource theory, and these particular method or particular concept we are going to use in this particular what we can say, the multiple resource time sharing model. Okay. Now let us go further. Now when I am talking about these three factors, let us understand this three dimensional what I can say model, 4-dimensional model. Okay. So one is processing stages, another is perceptual modalities, then visual channel and the processing code. Here it says there are 4 important categorical and dichotomous dimension. 4 important categorical and dichotomous dimensions that account for variance in time shared performance. Okay. Now let us understand each of them. First is processing stages. Now in processing stage, when we are we have some kind of information or some kind of some kind of information, then what we need to do, we have to first perceive it and then respond it, right? Here we say perception, then recognition or cognition, and then responding. Now here in this particular figure, you can see that perception and cognition are together and then responding, right? So it's dichotomous. Okay, these two are perception and cognition and then responding. This is, now when I am talking about the perceptual modalities, when I am talking about perceptual modalities, one can be visual, another can be auditory. So here it is visual, this particular thing, and then auditory. Now when I am talking about the visual channel, one can be focal, another is ambient. here you can see that focal, this portion, and then ambient, right. Now, when I am talking about focal, what it says? Fine details and pattern recognition. Focal means very much detail, right. So, fine details and pattern recognition, whereas in ambient you are actually looking at the peripheral visions used for the sensing the orientation and ego motion. Fine. The next is processing the code. One can be spatial, another can be verbal. In spatial it says manual responses like tracking, steering and all those things. Another is verbal responses. So, in this particular way we can actually represent all these 4 dimensions. Okay. So, this is the 4-dimensional multiple resource model. This is the actual model. Now, let us go further with the multiple resource model, that particular steps that we are going to follow. So, first step is coding the time shared task. When we start with the coding of the time shared task. Once that coding is done, then what we do? Calculate the total demand score. Now, this is very much important for us to understand over here, that it is very much skill based. You know, it's from lot of learning you will be able to code them. There are always it is possible that there are difference in opinion in some cases, you know, when we are actually coding. That we will come to know in the next slides. Okay. Once we calculate the total demand score, we actually calculate the resource conflict score. So, we have total demand score and then we are trying to understand where are those conflicts. Then to calculate the interference score. Once we understand the conflict, we understand the interference, and from there we actually apportion the interference score, then extend that particular model and apply that model in that particular situation. So, let us take all these steps in more detail. So, coding the time shared task. Each task is coded by the extent to which it depends on separate resources defined by the 4 dichotomous dimension. Whatever dimensions we have understood from that particular model, this particular model is very important. So, you know, perception, processing stage, perceptual modalities, visual channel and the processing code. Under that, all these dichotomous factors you need to understand very critically from that particular system, and then you have to establish that. So, then only you will be able to code them. Visual, then auditory. For visual channel you have focal and ambient. In processing you have spatial and verbal. Okay. So, what it says? That each task is coded by the extent to which it depends on the separate resources defined by the 4 dichotomous dimensions. Then demanding level within each resources can be on simple integer values 1, 2, 3 something like that, with greater demand implying the greater value, greater demand, greater value. Each task spawns with what is called the demand vector. Okay. The average level of demand across all resources are involved. For example, if it is simple conversion task, it is 1. If it is simple conversation task, it is 1. If it is a vigilance task, it is 3. Now, this particular 1 and 3, assigning this 1 and 3, this example has taken from this particular paper, this particular reference. Okay. So, if it is simple conversation task, we take it as 1, and if it is vigilant task, because you have lot of resources involved for that, then it is 3. Now, let us go into more detail. So, again that factorial understanding. So coding a very simple conversational task. Here it says perception, auditory, so 1, working with a memory, that is verbal, that is 1, and the responses is 1. Okay, so all are 1, 1, 1. Whereas when I am talking about the coding of a demanding visual task, like detecting the weapon in X-rayed luggage, then what we are going to do, perception, visual in focal and spatial, both vision, focal and spatial. So in that case we are giving a number, assigning it as 3, whereas responses we have vocal or maybe some manual activity, so it is 1. Maybe working memory we may not need, so it is 0. So now if we try to code them, so that is the next step, which is calculate the total demand score for the visual demanding, vigilance demanding task. It says the total resource demand is 3, because 3, this is 3 plus 1 plus 0. Okay, so it is 4. Okay, so the total resource demand for 2 timed shared task is summed to predict a total demand score component, and for this particular example it is 4. The larger this score is, the greater is the amount of interference. So from this particular score we can understand that if there is an requirement of the intervention or not. From the next steps we will understand where the intervention is required. So here we understand the intervention is required or not. In the next phases, the results, we will see interventions are required at which direction and which step. Okay. Now next step of this particular method is calculating the resource conflict score. What it says, the resource conflict score component is computed based on the extent to which the 2 task demand overlapping resources within the 4-dimensional model. So overlapping, okay, because that is the main agenda of this particular method, that we are trying to understand where those overlappings are and how they are actually interfering in the whole performance, okay, individual task performance. So the resource conflict score component is computed based on the extent to which the 2 task demand overlapping resources within the 4-dimensional model. Each task can compete with each other. Each task can compete with each other task for common levels like 0, 1, 2, 3, like that. Okay. A multiple resource conflict matrix is employed to calculate the amount of interference between task element. So we need to really draw a resource conflict matrix that we are going to show in the next slides. So with the number of shared resource feature with the other task. Now a 2 simple dimensional model need to be employed to understand whether task is spatial or verbal and the level of its demand on perceptual cognitive versus perceptual cognitive versus the response resources. 2 things. One is whether the task is spatial or verbal, and the level of this particular demand on perceptual cognitive or the response resources, that we need to understand. Higher the values within each cell indicate the greater conflict. Understood? So now let us understand how do we write that particular matrix. Now here is task A and task B. Now first understand these. Okay. So all values are bounded within 1 to 0. 1 means maximum possible conflict, whereas 0 means no conflict. This is again again the example is taken from this particular reference, and it's a simplified two-dimensional conflict matrix. It can be more. Okay. So, right now we are talking about, for our learning, we are talking about two-dimensional conflict matrix. So, all values are bounded between 1 to 0. 1 means maximum conflict, 0 means no conflict. Each cell, like these cells, okay. So, these cells that shares an additional resources between its row and column increments the amount of conflict by 0.2. A greater conflict between the response component of two tasks than between the perceptual and cognitive component. Identical resources between two tasks involve the greatest conflict. So, colored with these oranges, like these cells and these cells. As mouth cannot produce different vocal responses for two different tasks at the same time, it is not possible, right? For two separate tasks, you cannot speak simultaneously together, it is not possible. So, the maximum conflict value is 1 is placed in the bottom right cell, because it is not possible. If you are talking about verbal, and both the cases you need verbal, it is really not possible to produce it, right. So, it is maximum possible conflict. Okay. So, it is not possible. So, if you have to give a command to both the task verbally, you cannot do it at one time. You have to say give the command for first and then second, okay, depending on the priority. So, you cannot do it. So, that is why it is maximum conflict, and that is why it is 1. Fine. So, you understood this particular matrix. This matrix is very easy. Now, you have given this spatial and verbal, and then spatial and verbal for the perception and cognition, cognitive, and then responses. For here also you have written this, and then you mapped this particular model, and you created this particular matrix for task A and task B. Now, here it is 2 tasks, it may have 3 tasks or 4 tasks. Okay. So, according to the number of tasks involved for this analysis, the matrix will be more complex in nature. The 4th step is calculating the total interference score. What it says? The sum of total demand component and the resource conflict component determines the total dual task interference score. Total dual task interference score. So, if you have 2 tasks doing, so what it says, that total task interference score. Now, 5th step is apportion the interference score. It says this interference score can be apportioned or allocate to one task or the other, or both, as a function of how the operator is interfered to prioritize the 2 tasks. Here I said, suppose for 2 tasks you have to give vocal command, okay, verbal command. You cannot do it simultaneously. So, the operator needs to prioritize it. So, how these interference can be eliminated using the system design, so that prioritization becomes more easy for the operator. So, here the decision makings come, right. So, if it depends on the operator's decision, then there is always a chance of error, there is always a chance of an accident. However, if system defines, yes, this should be the process, then there will be less chance of error, less chance of accident. So, here is this apportion actually help us take the decision for the designer. It helps the designer to take the decision how to design it, so that there is this particular conflict can be overcome, you can overcome. Okay, so this is very important and crucial step in the system design, because if we cannot design it correctly, then there will be always a chance that we are depending on the operator's decision. Okay, so if that is so, then there will be always a chance to read that particular situation, and there will be a chance where we can have some kind of accidents. Okay. Now next step is extending this particular model. So a simplified two-dimensional conflict matrix can be you can extend in two ways, majorly two ways. First is, if it is desired to include differences between auditory and visual presentation, then the perceptual cognitive entries get expanded from 2 to 4. Okay, so perceptual cognitive entries get extended from 2 to 4. This is one way, and the second way is the certain special circumstances may require adjustment of the values in certain cells within the conflict matrix. So it is depending on how do you want, you can do this kind of extension. So in this particular case, it says the value in any cell characterizing the visual conflict between two tasks must be elevated to the extent that the two sources are separated out, because if it is separated out, then it becomes very easy for the operator to go ahead with the system. Otherwise, if it is connected with each other, these resources are same, then it is again a decision making, again there is a chance of error. Okay, so this actually help us to give a direction where the intervention can be. So we can understand from these code, we can say the intervention is required or not. From all these steps, we can understand where the intervention is required. Okay, so first says that it is required or not. The next, all these steps help us to understand where we should start, where we should take the decision, okay, being a designer or being the system controller. Okay. Last step is the applying this particular model. So any language based task or any task involving symbolic meaning is classified as verbal. Demand label should be kept simple, because if it is more complex, then it becomes very difficult for someone to analyze it. So demand level should be kept in simple at low values. Where there is doubt, the values within any level of the demand matrix can be set at either 0 or 1. There is no firm basis of establishment the relative weightage between the demand and the resource conflict components of this particular model. So here the experience matters, skill matters, if you keep on working, you will understand how to assign them. The absolute level of interference is of less importance than the relative level comparing two dual task condition or time sharing interference. Now let us understand the advantages of this particular method. So it captures known empirical phenomena that influence the dual task performance in many multitask environment. Okay, so what it does, it captures known empirical phenomena. Okay, it's very known to us. However, it helps us to understand those influences in the dual task performance, okay, in multitask environment. It is based upon a particular theory. So theory is already established. So multiple resource theory, that is very established theory. So this particular tool is very beneficial because it is already tested. So simple in its computation, relatively robust to simplification, because you can do very simplified thing. We will take it in the next slide. So, flexible in its adaptation, because you can have lot of flexibility to do lot of changes or lot of permutation combination in this particular tool or method. So, these are the advantages. However, there are a lot of disadvantages. Every tool has, every method has advantages and disadvantages. So, it requires some modeling experience, because if you do not have, then you will not be able to code them, that conflict matrix you will not be able to create. So, requires domain expertise to estimate the demand value. That was my very take, that if you are not experienced enough, you will not be able to give the right code, right value to those activity. Okay. Model output does not translate into direct absolute measure of dual task performance, but rather it yields a relative measure of task interference between the different dual task combination. It has received only limited validation and does not account for all multitask phenomena. In particular tasks, switching and the cognitive tunneling model assumes operator is trying to time shared task. It says that operator is trying to, however, it is not completely true. Okay, so these are the advantages. Now take more example for this simplified two resource conflict. You can say from this table we have simplified from this particular table, we simplified here for more understanding. So, task A and task B, perception and cognition, and the responses. So, these red zone are difficult and green zones are less difficult. So, this particular matrix shows the greater conflict in the negative diagonal than the positive diagonal, because if you have less conflict you can go ahead, whereas if you have more conflict you need to really look into. Like if you talk about 1, it is really not possible. So, it portrays the inability to respond towards two tasks at one time, like 1, and the greater capacity to time share the perceptual cognitive aspects of a paired task. Okay. And this is the what it says, that this is like combination, permutation combination. Okay, AA, BB, CC, AB, AC, BC. So, how you can do the permutation and combination. So, from these conflicts, from the same table we referred it and then we calculated this inverse. Again this is from that particular reference. So, task A, it says that pure demanding and monitoring. So, its vector of demand across the two resources is 2. Task B says the standard information transmission involve perception and responses, and task C is a tracking task. It's a tracking task but has an incompatible control. So, demands are 1 and 2. Okay. So, this way we have defined it, not from the example it is defined, and the demand components are computed by summing the average demand across all the resources within that particular task, negative diagonal, and across both tasks if it is positive diagonal. Okay. We understand this is negative, this is positive. Okay. So, the conflict components are computed by summing the conflict matrix components of all cells that are demanded by the both tasks. Okay. This is how we can implement it or use it. Now, let us understand what is the approximate time for if you want to use it, what is the kind of approximate time you require. So, it says that approximately 5 hours for a simple dual task problem. approximately. Okay, so you can have break also in between, and training time decreases to the extent that the user has greater familiarity with the cognitive task analysis with the domain of application. It's very true for all the methods, and you need only pen and paper to compute this. So, you do not need any kind of software or all, you can use simple pen and paper to use this for using this particular tool. Okay. So, this is very useful method, however, it is not very complex if you have good understanding about the perception, about the cognitive task, and about the domain knowledge of this particular method, then definitely you can have good data and you can take better decision that where the interference are and how you can give the solution towards it. Okay, that's all for today. So, I suggest again, as I do for all the methods, you take up a task and do the analysis, you create the matrix and try to understand if the interferences are there or not. If interferences are there, how do you go for the more detailing, and how do you go for the intervention to avoid these interference, because as long there are more interference, there are more chances of accidents, more chances of error and mental workload. Okay. If interferences are more, mental workload will increase. Okay. So, right now we are talking about mental workload. So, this is how we can do this analysis and we can take advantage of it and we can implement to enhancing the whole system performance in terms of human operator, in terms of the whole system. Okay. So, that we can do. So, that's all for today. Let us take the last topic of this particular cognitive like mental workload in the next class. Okay. Thank you.